Hey, what's up? This is Madan here, and maybe you know me or you probably not. But I'm right now, going to do, another video from electrochemistry, and this time it's really important for the board exam. And the topic I'm about to, make you go through is the variation in conductance or variation in conductivity or variation in molar conductivity with dilution. So there are three basic terms I'm concentrated right now. I repeat back. One is your variation in the conductance with dilution. Another is the same one, but it's for conductivity, and the third one will be for the molar conductivity. So this is really something very important, because this is not just important for the board exam. I repeat again, there are always some topic where most of the people who make the question paper, they are always concentrated about those topic where they can generate question, where they can generate some curiosity. So this is the topic. So what I'm going to do is I'm going to take that very topic I just said. So the topic we have variation in conductance conductivity and molar conductivity. Molar conductivity with dilution. First thing I have in my mind is to make you know what is dilution. Remember, I will be telling you one by one about. So the first thing is about dilution. Second, I will be talking, effect of dilution. Effect of dilution on electrolyte solution. On electrolyte solution. And then I will talk to you about the change in conductance. Change in conductance conductivity and molar conductivity. So these are, the key points I'll be discussing with you, right now. So let's start with the dilution. Let me repeat back the topic. I'm talking about the effect of dilution on the conductance. I'm talking about the effect of dilution on conductivity, and last but not the least one, I will be talking about the effect of dilution on molar conductivity. So for doing these three topics, the first thing I have in my mind to make you go very easily is let you know what dilution means. Dilution refers to increasing the concentration of water. Concentration of water. Right? If you increase the concentration of water, volume increases, volume of solution increases, but concentration of ions per unit volume decreases. So dilution is that simple. What dilution is? If you have an electrolyte solution, and suppose you got some you have a solution right here, where you have added some 5 gram NaOH, and initially you have 100 gram water. 100 gram water, right? Then what you do, you dilute the solution, so the salt remains same. The salt remains same, but you increase the water, like make it 500 gram. 500 gram H2O. So this is what called dilution. You are increasing the concentration of water. That is what dilution means here. Now, if you dilute a solution, what happens? The volume of the solution increases, but the concentration of ions per unit volume decreases. So this is what dilution I have done. I hope this was really simple and you have understand. So let's go back to the main topic. Now let's talk about variation in conductance first. Variation in conductance on dilution. Dilution. There are two situations. One is for weak electrolyte. One is for weak electrolyte and other is for strong electrolyte. Strong electrolyte. I hope you do know. There is change in conductance while you dilute, but for weak electrolyte and for strong electrolyte, the change is a little bit different because the reason behind is different. But overall, I would say it increases. Conductance increases. Let me write here. Conductance increases. There, conductance increases. So what that means, in both cases, on diluting a solution, what happens, whether it is for weak electrolyte or it is for the strong electrolyte, the conductance in both cases increases. Let's go for the reason why in both cases the conductance increases. What happened, if you remember, for weak electrolyte, the alpha, if you remember, alpha is called degree of dissociation. From equilibrium, you might remember, or I have done it, earlier in the same chapter. So alpha is small. Alpha is small. So if alpha is small, ionization is small. And if ionization is small, so if you increase the concentration of water into it, on adding water, alpha increases. And therefore, number of, let me wipe this off. Therefore, number of ions also increases. And hence conductance also increases. I need to explain this, though it's a very simple line here, but I'm going to explain you, right? In case you need to make take a look at that, but you can also make it later. Let me repeat that. For a weak electrolyte, the ionization is not 100%. So what that means? Alpha is very small. But if you dilute or if you add water into a solution, what happens? The ionization of the electrolyte increases. So on dilution, the ionization increases. What that means? Alpha start increasing. If alpha increases, number of ions per unit volume also increases. And if number of ions per unit volume increases, of course, the conductance of electrolyte solution will also increase. So that's what I have made here, right here. Let me explain that. Weak electrolyte conductance increases on dilution. There, alpha is small. So ionization is also small. But when you add water, the alpha increases and therefore number of ions also increases. Let's focus right here. Number of ions also increases, and if number of ions increases, the conductance also increases. So I hope you have understand the reason behind why conductance increases. Let me take you through the second part, which is our, strong electrolyte. So strong electrolyte. In strong electrolyte, as I said earlier, the conductance, let me go with the initial. Alpha is 100%. Alpha is 100%. What that mean? A strong electrolyte like NaCl, for example, I'm taking NaCl, maybe HCl, maybe NaOH, and etc. I'm not taking so much example here. So what happens if you add these salts, these substances in water, they completely ionizes and produce 100% of ion. So what that means? If you dilute the solution, there is no increase in the concentration because you cannot increase anything beyond 100%. I repeat that. On dilution, what will happen? That's something else. But what will not happen? That's something important. After you add water into the solution, the alpha will not increase beyond 100%. So how the conductance will increase? Actually, on dilution, forces of attraction between the ions decreases. And the force of attraction, let me underline this, the forces of attraction between the ions decreases. And if forces of attraction decreases, the ions start moving with a rapid speed. So what happened? Per unit time the movement of ions is increased. Like I was saying, we need to use this. So what happened, on dilution, the alpha remain 100%. Like what I'm talking about NaCl maybe. I'm talking about HCl because this is also a strong electrolyte, and like NaOH also. So on dilution, the alpha remains same, but forces of attraction between the ions decreases. The force of attraction between the ions decreases, and therefore movement of ions increases, and finally the conductance also increases. The conductance also increases. So this is what the concept for strong electrolyte here. There's a little bit right here, but then there is also, I have mentioned the same thing here. Like I was saying, for a strong electrolyte, alpha is already 100%. What strong electrolyte are? NaCl, HCl, NaOH. So on diluting, the force of attraction between the ions decreases. I've repeated the same thing right over here because the forces of attraction decreases, and what makes the force of attraction decrease? Increasing the speed of the ions per unit volume, going faster and faster. And if movement of the ions increases, the conductance will also increase. So let me repeat back the whole thing. Conductance due to weak electrolyte increases due to increase in the number of ions, but conductance of strong electrolyte increases due to decrease in the force of attraction. So I'm going to write that again here. This is going to be the key of this whole discussion I just been through. Weak electrolyte, dilution, dilution, alpha increases, so conductance also increases. Now, strong electrolyte, dilution, alpha remains same, alpha is 100%, yeah, alpha remains same, but forces of attraction between ions decreases, and therefore conductance increases. So this is very, very important. In case anyone is interested in making a short explanation about, this is going to help you out. So this is what the conductance and the effect on the conductance on dilution is. Now let's variation in conductivity. Conductivity on dilution. Right? This is going to be a short one, so don't worry about it. So the first thing, let me repeat back, conductivity represented by K, it's called kappa, if you remember. Kappa, some people call it kappa, whatever. Conductance of all the ions present in 1 ml solution, or 1 ml electrolyte solution. This is what called conductivity, right? If that was the definition. So what that mean, we can also represent K is directly proportional to number of ions per unit volume. This is what we can write. Now there is something easy coming up. If you dilute a solution, what happens? The volume of the solution increases. You are adding water, so the volume of solution increases. If the volume of solution will increase, what will happen? Number of ions will decrease. So on dilution, volume of solution will increase, and therefore number of ions per unit volume decrease, and therefore K will also decrease, because density of ions decreases. So let me repeat back. This is also done. What conductivity is? Conductivity is the conductance of all the ions present in 1 ml of a solution. So when you dilute a solution, the volume of solution increases. If the volume of solution increases, the density of the ions will decrease. And if the number of ions per unit volume is decreasing, since conductivity is based on number of ions, so number of ions will decrease on dilution, and therefore the conductivity decreases. So I hope you have understand. Now I have to take you through the next one, which is the molar conductivity. So in case you need to make a copy of that, let's follow this, and then I'll be wiping this off. So with this we have come to the last topic, and that is the molar conductivity. Molar conductivity. Right? So the topic is variation in molar conductivity on dilution. If I repeat, lambda m was K into 1000 divided by M or C, because molarity can also be represented as, C. So let's define it. Conductance of all the ions present in 1 mole of electrolyte solution. This is the definition here. Electrolyte solution. Right? Now let's concentrate back here. When you dilute the solution, what happened? The volume of solution is increasing. Volume increases. Now volume increases, ions decreases, right? Ions decreases. Now what you see out here, that molarity is inversely proportional to the lambda. So what we see, that if you are diluting, the molarity decreases. So molarity decreases. And if molarity decreases, you can also write it like, the molar conductivity increases. Molar conductivity, I hope it's coming, increases. So this is what the whole concept is. Let me repeat back. What is molar conductivity? Conductance of all the ions present in 1 mole of electrolytic solution. When you dilute a solution, what happens? On dilution, the volume increases, number of ions decreases, molarity also decreases. But if you concentrate right here, if you see, molarity is inversely proportional to molar conductivity. So if molarity is decreasing, molar conductivity will increase. So with that, I have finally come to the end of this particular topic. I hope I have made you understand everything about. In case there was anything I missed it out, you can remind me, or you just let me know where I need to go back and do it again. In case you need to make a copy of that, let me stay away from here for 30 seconds or something. Now you have, in case you need, you can pause it right here and copy. This is really very, very important. Now let's get back to the, the very odd one. I have tried my best. There are something else, people have different ways, they can do. I don't know how good or bad I am, but one thing I know is that, I'm damn, true to what I do. So in case you like and in case you appreciate, that's going to be the best thing I can experience with this, online, teaching experience. So with that, I must say thanks for watching and, stay with me. Another thing, take care. Not only yours, but somebody who cared for you. Maybe your parents, maybe anyone out there, maybe you are unknown to them, but there are people out there who you need to take care. They need your help. In case you can do any moment, anywhere, don't hesitate, because this is what I want to do. This is what I want you to do, or anyone else out there to do. Right? Thanks for watching.